Okay, so alkenes are non-saturated, and we know that one non-saturated means that they have a double bond, so they can accept more things. They are non-saturated compounds with at least one double bond. We are going to study only the ones that have one double bond between two consecutive carbons. This makes the alkenes very reactive. So we are going to build up a table next, the same as we did with the alkanes, with the name, the molecular formula, and the displaced formula. We need a carbon that is attached to another carbon with a double bond, so we cannot have only one carbon. So methane does not exist. But the first one in the series is going to be the one that has two carbons. Then we have the one that has three carbons. So we can have like this, and there is only one double bond there, so there is no problem. How many hydrogens we are going to have in this one? Well, this carbon has already two bonds, so it's going to need two hydrogens. And this one is going to need also two hydrogens. In this one, be careful. This one needs two. 1, 2. Count every single atom of carbon to see how much they need. In this case, I need one only. That can be at the top or at the bottom, it doesn't matter. And then we have here 1, 2, and 3. Okay? So that is going to give us another formula. The last one, we have a problem here because we can have two structures actually. One is going to be this one, 1, 2, 3, 4. The other one also 1, 2, 3, 4. But the place of the double bond is going to make a difference. Now, if I put here the double bond, this is going to be my carbon 1. I'm going to begin counting from the closest carbon to the double bond. So this is going to be carbon 1, 2, 3, and 4. If I put it here, it's the same as this one because I should begin counting from the closest carbon to the double bond. So it's going to be 1, 2, 3, 4 again. So it's going to be exactly the same compound that we have here. But if I put it in the center, that makes a difference. So we are going to have two different positional isomers. They are isomers, but what it changes is the position of the double bond. So here we have 1, 2, 3, 4. Hydrogen, hydrogen. Be careful with the hydrogens. 1, 2, 3, and I need only one more hydrogen. 1, 2 here, so I need 2. 1 here only, so I need 3. And in this one, I have only one bond here, so I need 3. And this one has 3, so it needs 1. This one has also 3, 1, 2, 3. So it needs 1, and this one needs 3 to complete the 4 bonds that are needed. Now, how do we call these? Because this is going to be eth, and with the double bond, it's going to be ene. So the name is going to be ethene. This one is going to be propene. But in this particular case, we have two, so we are going to drop, we're going to separate the suffix and the prefix. So it's going to be bute and bute, dash, and then in. And this is going to have in the center a number, which is the number of the smallest number that I can put that contains the carbon with the double bond. In this case, we said we begin counting from here is between 1 and 2. 1 is the smallest number, so this is going to be bute 1-ene. And the second one, this one, if I begin counting from here, it's going to be 1, 2. So that is the 2 or the double one. If I begin here, is 1, 2. So anyways, it's going to be bute 2-ene in both cases. This is going to be for the structure A, and this one for the structure B.